Hello, welcome to a video of scientific notation and standard notation. So today we are going to cover materials from chapter 10, and I am going to teach you how to answer them correctly. Alright, so for scientific notation, what you're going to want to do is, suppose I had a number like, suppose 829. This is just an example. So 829. So to do scientific notation, what you need to do is you need to get the first digit and then all the other digits separated from a decimal point. So it looks something like that. But using that, what we're going to do is we're going to create the same value but using exponents. So let me demonstrate. So if we have 829, right? So the decimal point needs to be right here. So it has to go 2 spaces. 1, 2. So 2 spaces. 2 spaces. Alright. Now what we're going to do is, since it goes those 2 spaces, 1, 2, 3. So 3 spaces. My bad. Alright, so 3 spaces. And after that, we're going to write it in this form. And then we are going to times it by 10 to the power of how many spaces. So how much were there? 3 spaces. So we're going to get 8.29 times 10 to the third. That's how to write a number in scientific notation. If you didn't really get that one, I'll show you another example. For example, 7008. Another example. So you are going to want to have the decimal place right here because that's what it is. It's equal to 7008.0, and on for the zeros. But we're going to count the number of spaces that it takes to get there. So each individually. So 1, 2, 3, 4. So since there are 4 spaces, right? 4 spaces, we are going to make this 7.008 because that's equal to the same number. And then we're going to write times. So this is a European multiplication sign, just so you know. And 7.008, we're going to times that by the number of spaces we took, which happens to be 1, 2, 3, 4. So 4 spaces. So 7.008 times 10 to the fourth is going to be how you are going to write 7008 in scientific notation. Now let's go on to standard notation. Standard notation is, how can I say this? It's kind of the exact opposite, because instead of trying to get this to a decimal, we are reversing the decimal to a full number. So, for example, if I had 7.8 times 10 to the negative third, when we have a negative exponent in this scientific notation, we are also going to, so when you have a negative exponent, you're going to move it backwards. Same case for scientific notation. I'll go back to that. I'm sorry. So when we're doing something like that, it still has a 7.8, but it was in order to move that to the 7.8. So we're going to have to reverse it back. So 7.8, right? So this is going to have to go 1 space, 2 space, 3 space. That's it, right? So that was a bad demonstration. Sorry. 1 sec. 7.8. So this is going to have to jump ahead the decimal point by 3 spaces. 1. So 1, 2, 3. So 7.8 is now going to equal 0.00. Alright. So now that we moved it back, so this 7.8 times 10 to the negative third is now going to equal 0.0078. I know it's still a decimal, but this is how you are supposed to rewrite it. It's without the exponent. So that would be another example of, that would be an example of standard form. Now, going back to the scientific notation. If we have something like, suppose, I'm thinking, sorry. What can I say? So 9.8, right? 9.8. To get to that number, let's say we started off with 0.98. I know it's not really big, but hang on. So since this moves one space, so move to the decimal point, then right here, so that would be, sorry, just make one jump. So 1, 2. So in that case, we would have 9.8 times negative 10 to the negative 2. So if it's going backwards and it has a number less than how can I say this? Less than 98, like a whole digit number, then it's going to have to go back one space, so one digit could be there. So, yeah. And for back to standard notation. So, all right. Standard notation, let me give you another example. If I had 7.89. We can, and the origin, so 7.089. How could I write this? Times, okay, so we're converting it from there. And 10 to the 5th. I know it's only showing 3 digits back here, but don't worry, that there's a reason why. That's over here. So then we're going to put this, all right, so 1, 2, 3. So, and then we're going to add those extra 2 zeros, because now this is going to become a 2 because all of these 3 have taken up the spot up there. So then 1, 2. And then this would be the regular number. 708,900. That would be another example of standard notation. Thanks, and I hope you enjoyed the video.